In this video, we're going to learn about trigonometry. A trigonometric ratio is the ratio of two sides of a right triangle. We are only working with right triangles with trigonometry. The three most common are sine, abbreviated SIN, cosine, abbreviated COS, and tangent, abbreviated TAN. So we always are given an angle to start with. In this case, we're looking at angle A. If you go across the triangle to the opposite side, you have your opposite side. I abbreviate this OPP. Across the right angle, across the box, is your hypotenuse, and I abbreviate this HYP. Well, that means the last side has to be your adjacent side, and I abbreviate this ADJ. I always label my sides so that I don't mess up. All right, so sine is the ratio of the opposite divided by the hypotenuse. Cosine is the adjacent divided by hypotenuse, and tangent's the opposite divided by the adjacent. So you're given an angle. In this case, we're looking at angle A, so that's right here. We need to label, so if I go across, this is opposite. Across the box is your hypotenuse, and that means Y has to be your, adjacent. So again, sine is the opposite over hypotenuse. So now that I've labeled them, opposite hypotenuse, that's just x over z. Cosine is the adjacent over hypotenuse, so y over z. And tangent's the opposite over the adjacent, so x over y. We use SOHCAHTOA to help remind us of which sides to divide. So sine, would be opposite over hypotenuse. I like to write it like this so I can see it's actually a fraction, opposite divided by hypotenuse. Co, for cosine, is the adjacent divided by hypotenuse, or like this. And then TOA, tangent, is the opposite divided by the adjacent. So I will write this down every time I work these problems. Here it is again at the top of my page, SOHCAHTOA. So the first practice says find the sine and cosine ratios at angle A. So let's start with angle A. Go across and label it opposite, OPP. Across the box is HYP. That means 64 has to be the adjacent. Sine is the ratio of the opposite over hypotenuse, and now that they're labeled, it's easy to plug those numbers in. 48 divided by 80. If you want to reduce it, go ahead. Cosine is the ratio of the adjacent over hypotenuse, so 64 over 80. And that's it. Now let's come from angle T in this next example. Angle T is over here, so I'm going to go across the triangle to the opposite. Across the box is your hypotenuse. And there is a little error here. Let me fix this for you. This should definitely not be 10. It should be a 1. Okay, so back in business. That means that 1 should be the adjacent. All right, so sine is the ratio of the opposite over hypotenuse, so 2 over root 5. Now, we would like you to rationalize this, and that means you're getting rid of the square root in the denominator. You multiply by whatever is in the denominator. In this case, it's a square root of 5. So, square root of 5 divided by square root of 5. If you're multiplying the numerator and denominator by the same number, you're not really changing the value. You're just changing the appearance of it. All right. So the numerator becomes 2 roots 5, and when you multiply square root of 5 times square root of 5, you get square root of 25. Well, that equals 5. This is your final answer for the sine of t. All right, so cosine is the ratio of the adjacent over hypotenuse, so that would be 1 over square root of 5. And again, we're going to rationalize the denominator. You multiply the top and the bottom by the square root of 5. All right, so in my numerator, that's going to give me 1 square roots of 5, and the denominator, well, you'll get square root of 25, which is 5. And this is your final answer. If you want to leave that 1 off, that's fine. It means the same thing. Okay, this time we're looking for the tangent ratios of A and B. So let's start with angle A over here. Label opposite. Across the box is your hypotenuse. and the 4 would make your adjacent. Tangent is TOA, opposite over adjacent. So it's easy to see that would be 3 over 4. Now when you're coming from angle B, things change. So let me erase this. Hypotenuse stays the same, but this time when we're coming from angle B, 4 is opposite and 3 is adjacent. So just be careful with that. This time our tangent from angle B is 4 over 3. Let's try this again. Tangent of S. So we're starting with angle S. Go across, opposite, across the box is your hypotenuse, and that means 16 is your adjacent. TOA is opposite over adjacent, so that's 30 over 16. Coming from angle T, though, we're going to switch the opposite and adjacent. So from angle T, go across. This time, 16 is the opposite, and 30 is your adjacent. So opposite over adjacent, you would have 16 over 30. Notice what happens in both of these cases. When you're looking for the same ratio from the opposite angles, you get reciprocal values. All right, let's practice some more. Tangent 54 is x over 10. Well, we're solving for x. X is being divided by 10, so I'm going to multiply both sides by 10 to get the x by itself. So now x is equal to 10 times tangent 54. All right, let's see what that number is as a decimal. So 10 tangent 54, go to your Desmos. Let me see. I've already typed it in, but let me show you how to do that again. Type in your number 10, and then you're going to type in the letters TAN. It goes from italicized to just regular, and then you type in a parenthesis with your 54. One thing you need to check is your settings. Make sure you're in degree mode. I get 13 point, let's round to 1 decimal, so 13.8. My x is equal to 13.8. All right, so you try. Go ahead and pause the video and solve this problem number 1. Tangent 44 is x over 12. All right, I hope you tried it. Let's see, I'm going to multiply both sides by 12 this time to get the 12 out of the denominator. So x is equal to, well, 12 times tangent 44. Let's take that to Desmos. So 12 tangent, open parentheses, 44, and I get 11.6. X is equal to 11.6. And that's it. Let's try 2 more. Now this time we have x in the denominator, so we're going to have one additional step. First thing, let's get the x out of the denominator by multiplying both sides by the x. Well, now you can see it's out of the denominator, but it's being multiplied by tangent 29. All right, so I want to undo this multiplication and get the x by itself, so I'm going to divide both sides by tangent 29. Those cancel, so x is equal to 8.9 divided by tangent 29. Let's go to Desmos. 8.9 divided by tangent 29 is 16.1. X is equal to 16.1. All right, now again, your turn to try. Pause the video and try number 2. All right, well, I hope you paused the video and you tried it. I'm going to multiply both sides by x to get it out of the denominator. So x times tangent 42 is equal to 31. Well, now x is being multiplied by tangent 42, so let's get rid of the tangent 42 by dividing it off. X is isolated. 31 divided by tangent 42, take it to Desmos. So I've got 31 divided by tangent, open parentheses, 42, and I have 34.4. X is equal to 34.4, and that's it. Time for you to practice.